So hello everyone. Now from today onwards, we will be getting started with creating a data model. So on the screen itself, you can see that we are having these multiple tables over here, right? So how exactly these tables are related to each other, so that we will be learning in this particular section. So up till now, we have discussed that how exactly we can gather the information or how exactly we can gather these queries or these tables. Then we focused upon that how exactly we can go forward with the data assessment so that we can make sure that each and every single column that is there in the given data is proper, right? That idea we got, and then we went forward with the data transformation or the data cleaning in our Power Query editor. So the Power Query editor was at the back end, and whatever changes we can make at the back end to clean the data or to make sure that the data is in a proper shape. So all of these changes we have made up till now in the previous section, and now from this point onwards, we will be focusing upon that as soon as we are going to clean these multiple tables that we have gathered. So how exactly we can build a relationship among these tables, right? So in order to build a relationship among these tables, we will be going forward with this new section, and that is going to be regarding creating a data model. So in the front end itself, you'll get to see in this section itself, that is the model view, that how exactly these different data you can, or these multiple tables you can see over here, right? And you can see that these tables are not exactly linked with respect to each other, right? As there is no such relationship at this point you can see on the screen. So we will be going forward with that how exactly these multiple tables can be linked with respect to each other, or how exactly we can build a relationship among them. So this is something we are going to discuss in this section itself, and it's definitely going to be great. Just because if you are well aware of that, what exactly is ER diagram, or if you're having some knowledge in SQL, so definitely knowledge in SQL can give you a kind of boost in learning about these concepts, right? Just because most of the concept that we are going forward with in this particular section belongs to SQL itself. So that's why if you're having some basic knowledge about SQL, then it can be great to directly jump in this section itself, and we will be giving you this insight that what all topics we are going to discuss in this section, and you can see on the screen itself that what all topics we are going to discuss. I'll just write it down. So first of all, in this section, we are going to talk about that how exactly we can create a data model. Then we are going to discuss about the normalization, at what exactly we mean by normalization, right? So there is a topic that is normalization and denormalization. You will get to see about that is OLTP and OLAP. So these are the two techniques which you'll mostly hear about whenever you are working as a data analyst, right? So if you are working as a data analyst or data scientist, then most of the time you'll get to see this concept, and that is OLAP and OLTP. So this normalization and denormalization is a concept which is a bit similar to that. So definitely we will be going forward with this. And again, normalization is a part of SQL itself. So again, if you're having great knowledge in SQL, it can come out to be a great factor for you, right? And then we can discuss about the facts and dimensions. And then we can discuss about the primary and foreign key. So in one of the video itself, we have discussed about that what exactly are these primary and foreign keys. But again, we are going to discuss about these things in a more brief manner, right? And this is a kind of this specific concept that is regarding the primary and foreign key is an important concept in SQL itself. So again, knowledge in SQL will matter over here. And the next concept is going to be very important, and that is regarding the cardinality. So cardinality will be exactly defining that how your tables are going to be linked with respect to each other. So if you're having knowledge in SQL, again, you might would have heard about these terms, that is one-to-one relationship, one to many, many to many, many to one. So all of these relationships comes under this cardinality category itself. So again, knowledge of SQL will matter here, and then we are going to discuss about the filter flow, these common schemas. So filter flow will be giving you this insight that how exactly the data is flowing. And finally, we can discuss about the hierarchies as well. So these are going to be the important topics that we are going to discuss about. Definitely, we will be covering some more important insights as well, but these can be the important topic which you need to look into. So before moving forward, if you can just simply go forward with the concepts of SQL, and if you can just get a kind of brief knowledge about these concepts from SQL itself, then definitely learning from this point on about building a data model can be a bit easier for you. But still, even if you're not going forward with those concepts, we'll be definitely discussing about these different fields in this particular section itself. So now from this particular video onwards, we will be getting started with these concepts, that how exactly we can create a data model, right? So we will be meeting you in the next video to discuss about this concept in a more precise manner. So that would be all in this video regarding how exactly you can create a data model, and we will be meeting you in the next video with some more important insights regarding this. So thank you. All right, guys. So now we will be getting started with our data model. That's what exactly we mean by a data model, right? So on the screen, you can see these multiple tables that are there, and on the screen itself, you can see that these tables are not exactly linked with respect to each other, right? As for example, I can show you, like, let me just show you a kind of way in which you can link these tables together. So let us go with these two tables that we are having. So one of the tables we are having is the product lookup table, and I'm having the second table as the sales data, right? So I'll just show you a kind of way in which you can relate the table together and how exactly a data model looks like. All right, so we will be discussing that how exactly we are building the data model in the further videos itself, but I'll be just showing you that how exactly you can relate the tables together. So just have a look upon it. There is no need to get the idea that how exactly the things are happening at this point. We will be discussing about these things in the further videos, but at this point, just let us have a look upon how we can relate these tables together, or how exactly we can build a data model. So now from my sales data that is consisting of this information and my product lookup table, if I want to build a data model, then this product key column, I will be dragging and I will be dropping to the product key of product lookup. I'm going to click on save over here. So this will be taking some time, and you can see over here that we are having a relationship right now, right? You can see that these two tables are now being linked with respect to each other. So this line that you can see over here, this line basically specifies that now these two tables are being linked together. And if this lining that you can see, so this lining we used to refer it as a relationship. So if we are basically able to build this relationship or this line among these tables, so each and every single table, if it is joined together via this relationship itself, then we can refer this complete diagram as our data model. So if we are not exactly having these relationship among these multiple tables, then we won't be able to say that we actually came up with a data model. So if you want to build a data model, you must have this idea at how exactly you can come up with these relationships, right? And just in order to understand about these relationships, there is going to be some important concepts that we were discussing in the previous video. That is the primary key and foreign key, then the cardinality, then the filter flow, and then as you can see over here that we are getting this message that this relationship has cardinality as many. But what exactly is this many cardinality? And if it is showing us this message that the cardinality is one to one to many, or many to one. So what exactly do we mean by that? So that's why we were giving you a kind of a kind of suggestion that you can simply go forward with the sequel concept so that these things will be more clear to you. But definitely, we will be going forward with these things in the further videos. At this point, let us just have a look that what exactly do I mean by this statement when I'm saying that I'm building a data model. So whenever I'm building a data model, I will be relating these tables together via this relationship itself. So at this point, I won't be building it. So I'm going to delete it by clicking on right click over here in this relationship. And in some time you will be able to see that we are back with our original look that we were having right initially. But I've just shown you a way in which how exactly you can build this data model. So now why there was a requirement to relate these tables together, right? Why there was that specific requirement. So we will be discussing about this. Okay, so the major reason why we are exactly going to join these multiple tables together, or we are going to relate these multiple tables together via this relationship, so that the data that is going to be there into this specific table and into this specific table can be filtered via a common column that is going to be there in both of the tables. So as you can see, if you will just, look back in our video itself, then you can see that when I was trying to relate these two tables together, I was making the use of product key column from sales data with respect to the product key column from the product lookup table, right? So you can see that I was making the use of similar column that was there or a common field that was there among the multiple tables, which I'm trying to relate with respect to each other. So if you are able to do this thing, if you are willing to join the two tables together, so you always have to look forward to that specific column or that specific relation, which is going to be similar in both of the tables. So if you're having such a column which is going to be similar in both of the tables, then the things become more easier for you. You can easily relate the two tables together, and via making the use of that option, the columns from these specific table will be able to get related with the columns of this specific table. So if I'm choosing a specific column, like for example, product name that is there, and with respect to a product name, if I want the details like the order quantity and the complete details from this specific table, then I will be able to get that information, or I will be able to fetch that information via relating these two tables together. So that's why it's very important to build a data model, right? So that by making the use of the column of product lookup, I will be able to access the information that is there in the sales data table, right? So at this point, I will be showing you that if you're not relating the tables together, then what kind of values we will be getting. So let me just go into my report view. So report view, as I was telling you, the front end and back end video itself, that report view is going to be that specific space wherein you are going to create your dashboard, which the data analyst and the business analyst look upon to, so that they can make some important decision, right? Just because we are making the use of the latest version of Power BI, so that's why over here itself you can see these multiple visualizations. So we will be discussing about these things, that what exactly these visualizations are, what exactly these tools are, what tool we are making the use of at what point. So we will be definitely going forward with that in our a further section. But let us just go forward with this specific tool that you can see on the screen. So there's a matrix option, right? Like if I'm just hovering over here, you'll get to see that this matrix which is being shown over here. So this option I can just make the use of. So I'm just going to click over here. And on clicking over here, you'll get to see that now you're having this matrix, this newly created matrix that you can see on the screen, right? And if I'm just clicking over here, then you'll get to see that this looks like a bit like the pivot table, right? That we are having in MS Excel. So I will be just showing it to you that if you're not relating the tables together, then what kind of values you will be getting. So into my value section, let us go with the sales table. So in the sales table itself, let me go with a column as the order quantity. So it is fetching the data. All right, so we are getting a value over here that the sum of the order quantity is 84,174. And why it is only considering the sum itself, all of these important learning we will be going forward with in the section wherein we are going to discuss about these visualizations. All right, and now let me show you another table that we haven't linked with respect to this sales table, right? That is the product lookup table. So now if I need this information that with respect to a specific product name, or yeah. So with respect to a specific product name, what exactly is the sum of the order quantity with respect to it? So you can get this information, or you can also go forward. So in the value section, you won't be adding it. Let us go add this in the rows section, so that each and every single row will be showing it to you that what is the complete order quantity with respect to a specific product name, right? So let me again go back to my product lookup table, and yeah, this thing you always have to take care from your side, that when you are adding the values in your visualization, so whether if you're adding it in the value section or if you're adding it in the row section, these things you always have to make sure so that you can get the proper insight which you are looking for, right? So just because I want the product names to be shown in multiple rows, that's why in the rows section, I will be adding this data. So these things we'll be discussing in the visualization section itself, but I've just given you a kind of brief overview, right? So now in the product lookup table, let me go forward with the product name. And now you can see on the screen that for each and every single product name, I'm getting the total sum of order quantity as the same, right? So we are having the multiple different or distinct product name over here, but the value which we are getting with respect to it is coming out to be the same. And why exactly it is coming out to be the same? Just because we haven't related the two tables together. So if I would have been related the table, that is the sales table, with respect to product lookup table, then I would have got some proper value for the sum of order quantity with respect to each and every single product name that is there. But just because I haven't related it yet, so that's why you are able to see such kind of values, right? So that's why the relationship is important, and that's why the data modeling is important. Because if you're not joining the two tables together, or if you're not building a relationship among the tables together, then you won't be able to see such kind of visualizations or such kind of important insights, which will be helping you out to relate the fields of two different tables together, right? So you can see that why exactly the data modeling is important and why exactly we came across this section, right? So in the further videos, we will be going forward with that, how exactly we can build a data model, what all concepts we can discuss about, and with respect to each and every single concept, we will be getting started with from the next video itself. So this video, you have just got a kind of idea that why exactly the data modeling concept or data modeling is important for us, right? So we will be meeting you in the next video with some important concept in the data modeling section, and that would be all in this video. So thank you. All right, guys. So in one of our previous video, we were discussing about an important concept, right? That is normalization. So we were saying the statement that if you want to become better with respect to data models, then you need to have a kind of great knowledge about normalization. So it is true. So if you want to become a data analyst or a business analyst, then learning about normalization is a very important thing, right? Just because you need to understand that how exactly the data is being stored. If you want to go forward with the processing of the data, that is, if you want to bring in some changes into the data, like the insertion operation you want to perform, updation operation you want to perform into your table, or even the deletion operation you want to perform, or if you want to go forward with the analytics of your data, then you need to have a kind of proper idea that how exactly your data set is being represented, right? Or into your database, if you're storing the information, then how exactly your tables are being linked together. So that idea you definitely need to get, so that you will be getting better with the analysis process, right? As in the previous section itself, we were discussing that there is going to be a ETL technique, that is extract, transform, load, wherein first of all, the data engineers used to extract the information, then they used to transform the data, and then they used to load it in the data warehouse, right? So this is what ETL is. So the data analyst and the business analyst used to look upon the data that is stored into our data warehouse, and from there itself they used to perform the analysis, right? But the thing is that what kind of data is exactly being stored into the data warehouse? So the data which has been stored into the data warehouse is basically a denormalized data. So denormalized data is just the opposite of the normalized kind of data. And in this particular section, in this particular video itself, we are going to discuss about that. What exactly do we mean by this normalization, right? So there are first of all two techniques which we need to get, which we need to be clear about, and that is OLTP and OLAP. So OLAP stands for Online Analytical Processing, and OLTP stands for Online Transaction Processing. So this OLAP technique is something which is being used by the data analyst or the business analyst, wherein into the data warehouse, the complete data which has been stored. So onto that data, the data analyst and the business analyst with respect to that data, they used to perform the analysis. But onto the OLTP data, that is going to be the kind of data which the websites used to store, right? So if a front end back end engineer who are creating a kind of website, then what exactly they used to do is that they used to create these multiple entities. So for example, in your web page, if you're having one of like if you're having a kind of website which is storing the information regarding the patients. So if there's a specific website which is serving a purpose to allot a nurse to these old age patients, right? So this particular website, what exactly it will be consisting of is first of all going to be the hospital information, right? Wherein they are going to create a kind of form which will be storing the information regarding the hospital from where the nurse information will be getting entered, right? So that is going to be the first information that will be getting stored into a table. Then we can have a table which can store the information about the patients, right? Then we can have some another information which will be storing, or we can have some another table which will be storing the information about the contact us page. So if the user is having some query, so as per the query of the user, they can basically go forward with the contact us page. So this contact us page will be simply having a column which will be storing the message of the user, right? In a similar way, we can have some other entities as well, which will be storing some another useful information. So, what exactly a website or what exactly a full stack engineer is doing in that particular case is that is basically he is storing the information of multiple entities into multiple tables, right? So for a specific entity like user, he's making the use of a table which is being used to store only users information, right? In a similar way, for storing the information about the hospital, there is going to be a particular table which is going to store the information about the hospital itself. In a similar way, for contact us, he's going to make the use of a specific table which will be storing the information of contact us only. So that's exactly how the information is being stored in the back end of a website. All right. So for multiple entities, multiple tables are going to be there, which will be linked together. So in this particular scenario, the kind of data we have stored into our database, that is the multiple tables that we are making the use of, is something we used to refer it to as OLTP. So this online transaction processing is something making the use of these multiple tables to store multiple information, right? But as soon as I'm going to make the use of the process wherein I'm going to join these multiple tables together. So by joining, I mean to say in the last section itself, we were discussing about the joining operation, right? That is the merge operation we were discussing about. That how exactly the different tables can be joined together so that we can create a kind of wide table together, right? So after performing the join operation, when I'm going to relate these multiple tables together, then this particular new table which we have just joined, that particular table will be now referred as the OLAP technique. So this technique which is being used to join these multiple tables together is something we used to refer it to as OLAP, that is online analytical processing. So in the board itself, we will be writing these things for you so that you can have a kind of better idea about it. So OLAP stands for online analytical processing, and OLTP stands for online transaction processing, right? So this OLAP will be concerned about the analysis purpose, and this OLTP will be concerned about this operations like the insertion, updation, and deletion. So in the SQL language, we are having these sub languages, right? Like again, if you're having, you definitely need to go forward with the important concepts of SQL so that you can get a better idea about that what exactly this insertion, updation, or deletion operation is. So in SQL, we are having multiple sub languages, like we are having DDL, that is data definition language. Then we are having DML, that is data manipulation language. So the data manipulation language itself, we are having some of the important operations like the select operation we are having, insert operation, delete operation, or update operation. So these four important operations, which are being referred as a CRUD operation as well. This is something we are going to have in the case of DML language, that is a data manipulation language. So this DML language used to help us out with working with the data which we are going to store in the tables of the database. And if you want to work with the database, if you want to work with the schema of the database, then we can go forward with the data definition language, that is DDL, right? But definitely you need to have a kind of brief idea about these things, and then it will be a bit easier for you to get to know that what exactly do we mean by these terms, right? So by the select operation, which is going to be there in SQL, we used to select some useful information. So for example, if I want to filter out some, so if I'm having around 10,000 records, and out of these 10,000 records, if I want to filter out some specific data which I want to see, then I can make the use of the select operation. So the select operation will be helping me out to look into that specific data itself in which I'm interested about, right? In a similar way, I can have the other operation, that is insertion, which will be used to insert some data into the table. Then deletion is going to be to delete some data, which, or delete some row, we can say, into the table. And then updation is to update the record or the row that we are already having into our table. Just because in this particular DML we are working with the data, so as you can see that in the DML language itself, we are just focused about the manipulation of the data that we are storing into the table itself, right? So these operations, that is the insertion operation and deletion, when I'm going to join these multiple tables together, becomes difficult, you know. So first of all, if I need to give you the idea about the normalization, so from this point you can have a kind of great idea that what exactly normalization is. So normalization is going to be to organize these different tables together. So these different tables that you can see on the screen. So I need to organize them together such that these tables and these columns in this complete database. So this, you can read these multiple tables or the data model as a database itself, so that you can basically organize these tables together so that ultimately you can reduce the redundancy and you can preserve the data integrity. So I will be writing it over here. That is in normalization, we are concerned about reducing the redundancy itself, right? So this is what something I'm concerned about whenever I'm going forward with the normalization process, and that is going to be to reduce the redundancy, right? So whenever, so if I'm going to join these multiple tables together, as of the last operation that you might would have seen, that is the merge operation. Then after performing this merge operation, you will be able to see that a lot of data is getting repeated, right? And if the data is getting repeated again and again, then this repeated data or this duplicated data is something we used to call it as a redundant data. And definitely we don't want this redundancy, just because now at this point, if I want to go forward with this operation, that is insert, update, and delete. This operation, if I want to go forward with, if I'm going to join these multiple tables together, then these operations become difficult. So when I'm joining these multiple tables together, that is something I used to call it as denormalization. So as you can see that these multiple tables are not being linked together, right? So this arrangement that you can see on the screen, wherein these multiple tables have not been linked together, this is what normalization is. But as soon as I'm going to join these multiple tables together, then I will be coming across denormalization. Right. So whenever I'm going to move forward with this process wherein I want to go forward with insertion, updation, and deletion, then at that point of time, I always want this normalization to be there. Right. So this normalization always makes sure that these operations like insertion, updation, and deletion becomes a way much easier, just because now, first of all, you're not exactly going to have a kind of lot of redundant data. That is going to be the first benefit that you can get out of normalization. Secondly, by keeping the data normalized, you can also make sure about one thing, and that is each and every single table that is going to be there into your database will be solving a particular common purpose itself. So as you can see in the case that we were discussing, that is regarding the website. So in the website itself, I was telling you that we are going to have a table which will be storing the information about the users. Then there is going to be a table which will be storing the information about the hospital. Then there is going to be a contact us page. So in this case, you can see that we are having a specific table for solving a particular purpose itself, right? So a single table is being used to solve a single purpose. And that is what normalization is. But as soon as I'm going to join these multiple tables together, I'm going to go forward with the denormalization. And that is not something I want at this point, right? Like just because like you can see that if I want to insert some data into my user's information, so into my user's table itself, if I want to go forward with the insertion operation, so if I'm going to keep this data normalized, then just because by normalizing I'm making sure that I'm having a specific table that is present in a kind of alone form, that is not being joined together with respect to some other table. So just because this specific table is already present over here in a kind of alone format, you can call it as. So at this point, insertion would become so much easier for me. I can easily insert some new user information. In a similar way, if I want to delete the record of a specific user, then directly from the user table itself, I can delete the information, right? And even if I want to update the table, even if I want to update the user information, that is also something I can easily do. So these three operations become way much easier when I'm going forward with the normalization. But as soon as I'm going to denormalize data or as soon as I'm going to join these multiple tables together, these operations become difficult. As when I'm going to join the tables, that is the user's table with respect to the hospital information table. And then if I want to insert some information regarding the user only, then definitely at that point of time, I won't be having the information to store in the hospital table columns, right? As in this newly joined table, which has been just been normalized by joining the users table with respect to hospital table. And so in this table, we are having the columns of both user as well as hospital, right? But if I want to insert the record of user only, then what about the columns of the hospital table, right? That is also something I need to take care about. So that's why denormalization is not really preferred if you want to apply these three operations, that is insertion, updation, and deletion. And we always used to go forward with this normalization, right? So in this particular uh, structure itself, you can see that we are having these multiple tables which are separated from each other. So this is what something a normalized data look like. And when I'm going to, and this OLTP, that is online transaction processing, is works well on this normalized data only. That is the insertion, updation, and deletion. But just because if I'm interested in going forward with this analytical processing, that is the OLAP technique. So OLAP technique will be performed when I'm going to denormalize the data. So as I was telling you that I will be joining these multiple tables together. At that point of time, I will be going forward with the online analytical processing. So in the data warehouse itself, we are having the data stored in such a way such that these multiple tables are being linked together. So in the data warehouse, we are not exactly having the normalized data, right? In the data warehouse, we are going to have the denormalized data. Just because at that, in the data warehouse, the data analyst and the business analyst are concerned about performing the analysis on the data, right? So they won't be going forward with the multiple tables. As what they exactly want is that into a single table itself, the information from multiple tables should be there. So into a single final join table itself, the information from table 1, table 2, and table 3 should be there, right? And that's why into the data warehouse, they make sure that the table should be joined. But if you want to go for, but if you are looking forward to a process that how exactly the web developers used to store their information, then they used to go forward with this OLTP. So that the operation like insertion, updation, and deletion becomes easier, right? So this is what normalization is. So again, I can give you a kind of conclusion that what exactly is normalization. So in normalization, you will be organizing the tables and these columns so that you can ultimately reduce the redundancy or the duplicacy of the data, and you can simply preserve the data integrity. And the insertion, updation, and deletion operation becomes easier when you're going to keep your data normalized, right? And this is what OLTP technique as well is. So at this point of time, we are definitely, we would like to ask you that you can definitely go forward with learning about normalization at a depth, so that a more better idea you can get about the normalization, just because it is definitely an important concept in this particular section as well. Along with that, in SQL as well, it is a very important concept, right? So if you're working as a data analyst or business analyst, you definitely need to have a strong knowledge about normalization. So you can also go forward with this normalization, that what exactly it is, and we will be meeting you in the next video now with some more important concept, and that would be all regarding the normalization. So thank you guys, and definitely go forward with this definition from your side, and you can even look forward to some YouTube videos to learn more about this thing, right? So thank you guys. All right, guys. So when we were studying about the data cleaning aspect, or in our last section itself, we were going through the Power Query Editor, right? That how exactly what each and every single step we need to apply from our side. So when we were looking into the Power Query Editor, we were having one of the option, or we were having one of the step, and that was a data assessment step. So in the data assessment step, we were focusing upon that what kind of data we are exactly storing into our data set. So when you are trying to extract a particular file, a CSV file, so you will be looking into that what kind of data you are exactly storing into that file, right? So whether if you're having the numerical column or if you're having the categorical column. So that assessment you were doing from your side, right? So if the given column is consisting of these numbers, then you will be referring the specific column as a numerical column. In a similar way, if a specific column is consisting of these categories, then you will be considering that specific column as a categorical column. Just like that, we used to perform the assessment for the columns of the table. In a similar way, we can perform the assessment in such a way such that we can figure out that what kind of table we are having, right? So at this point, when you are trying to build a data model, you don't really need to look into that what kind of columns you are having, but you need to look into that what kind of table you are having. So on the screen, you can see that we are having around around 4 7, right? We're having around 7 number of tables, right, on the screen. So now out of these 7 number of tables, definitely we will be coming across some more tables as well. But at this point, out of these 7 number of tables, what exactly the category of each and every single table is going to be? Or I mean to say that how exactly you will be able to consider that what exactly is my product lookup table, and what exactly is my sales data table, and how exactly they're different from each other, right? So if you want to simply come out with this answer that how you will be able to figure out that what kind of table you are having, so for that you need to look into the columns of that table, right? So let us go with each and every single table so that we can get a more better idea that how exactly we will be differentiating among the different tables we are going to have. So you can see the first table that we are having is the territory lookup, right? So what kind of columns this territory lookup column is consisting, this table is consisting of? So first of all, we are having the continent column, then we are having the country column, then the region column, right? So now what exactly these columns are? These columns are nothing but a kind of descriptive features, right? A descriptive feature I can call it as, or the categorical columns. Like ultimately, if I'm having a specific column which is giving me the name of multiple countries, then that specific column is ultimately going to be a categorical column, right? In a similar way, if I'm considering the region is also going to be a categorical column. And in a similar way, if I'm having a continent, so continent is again a categorical column. So over here, you can see that what exactly we are getting, or what exact kind of features this territory lookup table is consisting of, is the descriptive features. So we are getting some descriptions over here, right? A kind of fields we are getting with respect to which we can basically differentiate that what exactly was my sale in multiple categories, right? Like country, like India is going to be one of the category, then USA is going to be one of the category. In a similar way, you are ultimately creating these multiple fields or these multiple categories, right? And whenever you are having such a table which is representing these multiple categories, that specific table you are going to consider as a dimension table. So this dimension table will be consisting of all of these descriptive kind of attributes which you are going to make the use of so that you can create these multiple fields, right? Like if you want to simply figure out that what exactly was your sale, then you will be looking into your sale by simply going forward with the multiple countries, right? You will be looking for that specific categorical column, which will be helping you out to create these multiple categories, right? And this that specific table which will be helping you out to create these multiple categories is going to be your dimension table. And in a similar way, first of all, I'll just write it down that what exactly we are going to, what exactly the two different kind of tables we are considering. So first of all, we are having this dimension table, and secondly, I'm going to have this fact table. All right. So Up next, we will be talking about that what exactly is fact table. So first of all, let me give you a kind of brief just note over here that what exactly is going to be a dimension table. So dimension table will be consisting of these descriptive attributes for grouping, right? So if you want to simply grouping or filtering, you can say, right? Grouping and filtering. So if you want to simply go forward with grouping technique, like for example, if you want to simply go forward with this answer that what was my sale in these multiple groups, then how exactly you will be able to create these groups. So for creating the groups, you need to look forward to such a kind of column, right? Like country India can be considered as one of the group wherein you can simply calculate the sale. In a similar way, if I'm going forward with the continent, so Asia can be one of the group which you can create from your side, which will be giving you this complete insight that what exactly is going to be the sale in the Asia continent. In a similar way, you are going to have some another continent wherein you can calculate the total sale, right? So that specific table which will be helping you out to create these multiple groupings and filtering that you can consider as a dimension table from your side, or in whatever table you can look forward to such a kind of column which is like a categorical column. That table you can again consider as a dimension table itself. So also we can look into the product lookup table. Again, in this product lookup table you can see that we are having these attributes like the product name. I'm having product name is again going to be a categorical column. So with respect to this product name, again I can create some groupings, right? Like product name with respect to product name one, we are going to have the first group, and then product name two is going to be the second group. So in this way, we are going to differentiate between the different tables. So when you are going to differentiate between these multiple when you are going to differentiate between these multiple groups that you are going to create, like for example, if you are looking into that what exactly was your sale in these multiple countries, then ultimately if you are creating these multiple countries from your side, or if you are just looking into the sale in multiple countries, then you have to associate a number over there as well, right? Like if you are showing that what was my sale in India as my first group, then what should be associated with respect to India, and that is going to be a number, right? And in a similar way, if you want to go forward with what exactly was my sale in some another country like China, then again you have to associate a number over there, right? But these kind of tables that is my dimension table won't be giving you the numbers. So if you want to associate a number with respect to these multiple groups that you are creating, for that you will be looking into our fact table. So this specific table, that is the sales data table, is going to be considered as a fact table over here. Now, why exactly you're considering the sales data table as a fact table? Just because it is providing you with those numbers, right? Now you can see that we are having one of the column over here, that is the order quantity. So if I need to get this idea that what was my total order quantity in each and every single group or in each and every single country, then that specific number which you are going to associate, that you can get from this sales data table only, right? So that's why you will be considering your sales data table as a fact table. So these two kind of tables only you are going to have. So just like you were having these categorical and numerical columns when you were doing the data assessment, in a similar way, you are going to have this dimension table and the fact table as your two different kind of tables. So whenever you have to simply go forward with the data, whenever you have to simply go forward with the data modeling, it's very important to get this idea that what kind of columns you're having. Just like when you're performing the assessment, it's very important to get to know that whether if you're having a numerical column or a categorical column, because the visualization that is associated with respect to a categorical column and a numerical column is going to be different from each other, right? Like for example, if you're trying to associate a numerical column with a categorical column, then you have to make the use of bar chart. In a similar way, when you are trying to associate these two numerical columns, you have to go forward with the scatter plot, right? So different kind of plots you will be going forward with for what kind of data you are storing, right? So that's why when you are creating a data model as well, it's very important to have this idea that what kind of tables you are storing in your data model ultimately. So the first kind of table that we are having is a dimension table that you can see that is going to be a territory lookup, just because it is having these kind of columns with which I can create these multiple groups or these multiple categories. And the sales data table is going to be a fact table just because it is providing you with those numbers. So I can just write this definition about it, that it provides with numbers which we can associate with groups, right? So your sales data table can be your fact table in a similar way. If one of the table is giving you the idea about the total number of orders, then orders quantity, as I was telling you, that it is just because a number, a numerical column. That's why, and just because this number you can associate with respect to these multiple groups. That's why again this specific table, sales data, will be considered as your fact table, right? So when we will be going forward with some more important concept that is there in data modeling, it will be very important for us to get to know that how exactly and what exactly is the kind of table we are having. That's because in the data modeling aspect, it's very important to get to know that what kind of table we are having. As after getting that specific idea only, we can go forward with building the relationship among these multiple tables. And you can see again that why exactly building a relationship is important over here, as when you are representing these multiple groups or these multiple country by making the use of this dimension table, that is the territory lookup, then how you can exactly associate a number that is going to be order quantity from the sales data table if you are not relating these two tables together, right? So that's why again you can see that why building a relationship is so important, so that you can associate the values from the fact table with respect to the columns of the dimension table, right? So that's exactly how you will be differentiating in between the different tables you are going to have, and definitely have a kind of great idea about these this definition, that what all tables you are having, just because in our next videos we will be making the use of this concept to come up with, to clear the aspect about some more important concepts, right? So that would be all regarding the fact table and dimension table, and we will be meeting you in the next video with some more important knowledge about the data models. So thank you guys. All right, guys. So the last video we were discussing about the two kind of tables that we can have, and that is going to be a fact table and a dimension table. So based on what kind of data you are going to store into your table and what kind of values you are exactly having into your table, as per that, you will be simply distinguishing in between the different kind of tables that you can have, right? So as we were talking in the previous video that if you're having the idea that now once you have figured this thing out, that you are having one of the fact table and you are having these multiple dimension tables, right? But how exactly you can relate them, right? For ultimately relating these tables, you need something, right? You need something which will be helping us out to relate these tables, so that ultimately at the end of the day we can build our data model. As building a data model is to simply go forward with the relationship that is there in between these multiple tables, and then relating these multiple tables together, so that finally we can have a model wherein each and every single table will be related with respect to each other, right? So when you are trying to relate these multiple tables that you are having, you definitely will be requiring something from your side, right? A kind of column you will be looking forward to in each and every single table, so that you will be able to relate these multiple tables together. Just in order to relate these multiple tables together, you will be making the use of these columns that we refer it to as a key. And these key columns are the primary key column and the foreign key column. So I will be writing this over here for your, you can see it. So I'm talking about the primary key, right? And I'm talking about the foreign key. So what exactly are these primary key and foreign key? That idea we need to get, right? So the thing is that when you're having a specific table, then what exactly is going to be that specific column which will be helping us out to differentiate between the multiple rows that we are having. Like for example, if I'm having around 1,000 number of rows, then which is going to be that specific column in my table, which will be helping me out to distinguish that how exactly the current row is different from the next row, right? The row number 566, how exactly it is different from 567. So as I was telling you these numbers like 566 and 567, so you can already get this idea that there are going to be some values, there are going to be some row numbers which will be helping us out to differentiate between the multiple rows, right? And these columns, which, or we can say that a specific column that is going to be there in a given table, which will be helping us out to distinguish between each and every single row from each other. That specific column we will be considering as a primary key, right? So these primary keys are going to be the unique keys, which will be consisting of these unique values. So each and every single row for a primary key will be having a unique value. So I like, it's like you are having the row numbers like 1 2 3 4 and like that, right? And increasing sort of numbers you can see from your side whenever you are creating a primary key. But this is just the example. But the thing is that what exactly is going to be that primary key is that specific column which is having the values which is going to be different from each other, and which will be helping us out to distinguish between the multiple rows that we are having, right? So we can make the use of this primary key, and you can see on the screen itself that we in this specific table that we are having as a customer lookup table, we are having this column as a customer key, right? So now we can see that in the customer key column, we are having each and every single value that is unique, right? You can see that we are having, or we can say that we are having each and every single value over here, which is helping us out to distinguish one row from another, right? So how exactly this specific row is different from this specific row? For in order to get that idea, you can simply go forward with this customer key. So customer key over here is going to be the primary key in this table, and definitely if you'll just hover down, if we'll just scroll down, you can see that each and every single row will be having a different value for this customer key, right? And this is what exactly we always used to look forward to. So whenever you are having a table, first of all, have a look upon that what exactly is your primary key over there. So primary key will be making sure about this thing that by making the use of this key, you will be able to distinguish each and every single row from your side. And there are some properties of a primary key that it can't be null. So definitely if you want to figure out that in which specific row you are. So for figuring that thing out, you are making the use of primary key. So if primary key is coming out to be a null value, then how exactly we will be able to get that specific row, right? So that's why it can't be a null value, and definitely it can't be a duplicate value, as if you are having the duplicate rows which are having the similar value for primary key. Then how exactly we can differentiate between those rows, right? So again, we will be making the use. So again, we can say the statement that primary key can't be duplicate. Then it should be unique and distinct. So already we have discussed about this thing that each and every single primary key is going to be unique, so that it will be helping us out to distinguish one row from another. Right. So once you're done with this primary key, let me show you some another table as well. Like if I'm just coming over here in this specific table, that is product lookup. So in the product lookup table as well, you can see that we are having each and every single value over here that is different from each other, right? So it is unique, it is not getting repeated, and for each and every single product that we are having a unique primary key for it. So each and every single row now can be differentiated by making the use of this product key. So you always have to look forward to that specific column which is having the different value for each and every single row, so that you can immediately differentiate among the different rows that you are having, right? So now once you're having this primary key, then you can move forward with the next key, and that is going to be the foreign key. So over here in this sales data table, you can see that we are having the product key. So this product key was actually a primary key in the product lookup table, right? In a similar way, this customer key you can see. So this customer key is also present, which was the primary key in the case of customer lookup. So it's those specific columns which are going to be there in your table, which is going to be the primary key for some another table. So that specific column will be considered as a foreign key for you, right? So if you want to figure out that what exactly is your foreign key over here, so you can simply have a look over this customer key. So customer key is present over here, but this customer key was the primary key for customer lookup. So that's why in this specific table, it will be a foreign key. In a similar way, product key was a primary key for product lookup table. So in this specific table, it is going to be a foreign key again. In a similar way, you're going to have this territory lookup. So in this territory lookup, you're having this specific sales territory key, which is the primary key over here. So in this specific table, that is sales data, this territory key is going to be the foreign key. So that's exactly how you can get this idea, right? So if there is in your given table, if there is a specific column which is storing the values for the primary key for some another table, then you can consider your this specific column as a foreign key for yourself, right? So now once we are having these foreign key and primary key, so these are going to be the keys which will be helping us out to relate the tables together, right? So for example, if I want to relate this sales data, which is my fact table, right? So with respect to this fact table, I'm having these multiple foreign keys. So for relating this sales data table, you can see that if I want to relate it with respect to customer lookup table, then this customer key that is present as a foreign key in my sales data table will be helping me out to relate with respect to customer lookup table with respect to the same customer key that is a primary key over here. So the foreign key of the fact table will be helping us out to relate with respect to the primary key of the dimension table. So customer lookup is my dimension table itself, right? Just because it is consisting of multiple categories. But my sales data table is my fact table. So fact table will be consisting of these foreign keys, which will be helping us out with to relate with the dimension tables with respect to their primary key, right? So that's why it's very important to always clear about this thing that what exactly is your foreign key and primary key, right? And now let us get back into our data model section. So already we have shown you that what exactly is going to be a primary key and foreign key, and it's very important whenever you are learning about SQL as well. So in SQL, these terms are like the most common terms. You will definitely come across the primary key and foreign key if you are learning about SQL, right? So again, data modeling is related mostly to SQL. So someone who is having a great knowledge in SQL, for that person, it will be like a basic terminology, right? So we have given you an overview about the primary key and the foreign key. So now let's get back into our data model section. And you can see that what exactly I've did from my side is that I have arranged these multiple tables together. So I have kept my fact table, that is my sales data table, on the bottom, and all of my dimension tables are placed above it, right? Like my territory lookup, you can see customer lookup, and all of these multiple tables. These dimension tables are being shown at above of the of our fact table, right? And into this data model itself, you can see one thing, right? That when I'm having this data model, each and every single table that is present over here is showing us some specific details, right? Like for example, this territory lookup is showing us the details about the continent, country, and region. So what exactly is the territory? That idea we can get by making the use of the specific table. In a similar way, if I need to get the information about the customers, then I can simply go forward with this specific table only, right? So this customer lookup table will be involved in giving me the idea about the customer details. In a similar way, if I need to get the idea about the calendar, the date, and each and every single information, then I can go forward with this calendar lookup. In a similar way, the description about product will be given by this product lookup table. Then the description about the product category will be given to me via making the use of this product categories lookup table. In a similar way, about the information about product subcategory will be given by this specific table. So you can see that each and every single table over here is giving us some specific information. And this is what normalization is. So in normalization, we make sure about this thing that in our data model view, each and every single table that is present should reflect a specific information itself. Like a specific table like territory lookup should give us the information about territory only. In a similar way, this specific table should give me the information about a specific category only. So that's exactly how I used to go forward with the normalization. So that's how you can get this idea that in normalization, if you want to see that whether if your given data model view is normalized or not. So in order to make sure about that, you simply need to go forward with each and every single table, and you have to look into the table that whether if this specific table is giving us some specific information or not. So if it is giving us a specific information, then we can simply say that all of these tables are being normalized. But if the given table is giving us the information about multiple attributes or multiple details we are getting, then we can say that this specific arrangement is not exactly normalized, right? So definitely when you will be merging the two tables together, as we have shown you in one of our previous video in the previous section itself, that when I was trying to merge the two tables together, then in that specific scenario, I was trying to get the attributes of two tables together, right? So so by merging the two tables together, you are ultimately creating a kind of table which is not exactly solving, or which is not exactly serving a kind of specific purpose, right? So that's why you always have to go forward with normalization, and you have to make sure about this thing that each and every single table in your data model view should reflect a specific information only, right? So definitely that's why you shouldn't be going forward with merging whenever you are going forward with the data model view. And you always have to make sure about one thing that each and every single table that you are having should have a specific should serve a specific purpose itself, right? And now let me show you that if I'm having a specific table like territory lookup, so how exactly I can specify that this specific column that is there, that is sales territory key. So that can be assigned as a primary key. So what exactly you can do is that you can simply click on the table. Let me go in the properties section. And you can see over here, we are having the key column option, right? So in the key column, I'm going to select for this for the sales territory key. And you can see over here kind of symbol is being created, right? Like a like a ID card. So this symbol so this symbol basically denotes this thing that this specific column will now be considered as a primary key over here. So this specific primary key will be helping us out to differentiate among the different rows. In a similar way for customer lookup, you might would have already come across this specific column, and that is this customer key. So this customer key is going to be a primary key over here. So again, when you're selecting it, it will be having a symbol in front of it. You can again see this customer key is now being treated as a primary key over here. In a similar way, let us go with calendar lookup. We are going to go forward with key column in the properties section, and date I'm going to consider as my primary key. Similarly, for product lookup, we are going to have our key column as product key. Just like that for product categories, product category key. In a similar way, for product subcategory, we are going to have this product subcategory key. But in your sales table, you can see over here that we are not exactly having any column, right? Which is distinguishing between the different rows that we can have. Like there is no such thing as sales ID. We are having the foreign keys over here in our fact table, but we are not exactly having a primary key. So generally, you will be able to see that into your sales table, you will be having something like a sales ID as your primary key. But in this particular data set, we are not exactly having that sales ID, right? But still, it's fine with respect to the other dimension tables we are having just because we have assigned that primary key over there. That what matters. So you always have to make sure about this thing that whatever dimension tables you are having, you always have to associate the primary key for them, right? So that simply makes the relationship building a bit more easier, right? Just because later in this section we will be getting this idea, we will be looking into that how we can make the use of the foreign key of this fact table that will be associated with respect to the primary key of this dimension table. So that's why associating our primary key with respect to this dimension table is going to be too much important for us, right? So you always have to make sure about this thing that you have to associate, or you have to make sure that the primary key with respect to each and every single table has already been associated. So that specific primary key of the dimension table can be related with respect to the foreign key of our fact table, right? So that would be all regarding the primary key and foreign key. So these changes you can make from your side as well, so that in the next videos it will be a bit easier for us to relate these tables together. And finally, we can see our completely built data model, right? So these changes you can make from your side, and that would be all in this video, and we will be meeting you in the next video with some important learning. So in the next video, we will be focusing upon that what is going to be the difference between the merged tables and this relationships, right? So that you can have a kind of better idea that why we are not exactly telling you to merge the tables together. So that we will be discussing in the next video. So thank you guys. All right, guys. So as we were discussing that in this specific video, we are going to discuss about the merge table versus the relationships that we can build over here among these multiple tables that you can see on the screen, right? So before we had this Power Query Editor option, or we had this Power Pivot option, or this DAX option. Before that, we were making the use of these merged tables only. But the thing is that in the previous video we were discussing about the normalization, right? That if we want the tables to be normalized, then what exactly we want is that each and every single table should reflect some specific information, right? Like this specific table should give us some details about the specific criteria, or some specific field. In a similar way, the customer lookup table should give us the details about some specific field. So in that way, we can achieve normalization. And if we are working with these multiple tables, then at the end of the day, we want normalization only. So for achieving normalization, we first of all can't merge the tables together. Just because if I'm going to merge the two tables together, then the properties of one of the table will be associated with respect to the properties of the second table. And that would not gonna help us out to have a single table which is reflecting some, some unique information. So that's why we can't actually go forward with the merge table. That is one of the first reason. Secondly, if we are trying to merge the tables together, then we can create a lot of redundancy. So if you are trying to merge the two tables together, you will get to see that lot number of rows are getting repeated. And again, we don't want the redundancy. So that is again the second reason why we will be not going forward with the merge table. And then if you're working with a large amount of data and if you're just keep on merging the tables together, then on keep on merging the tables together, you'll get to see that this specific merge table, which is consisting of a lot of number tables which are being joined together, consumes a lot of memory, right? So you will be requiring a lot of memory and you will be requiring a lot of processing power if you are trying to merge the different tables together as compared to that of the relational model that you're building over here, right? But if you're trying to build this relational model that you can see on the screen, one thing you can achieve, and that is first of all normalization. Secondly, via applying the normalization, you'll get to see that which specific table is serving what purpose. Then you will be able to distinguish between the fact table that you are having and the dimension table that you are having, right? So you will be simply able to figure out that whether if my given table is a fact table or whether if it is a dimension table. So that specific info you also be getting via making the use of this normalization. So definitely whenever you are working with data analysis tools or you're working with any of the data analysis problem, you should always make sure that your tables are normalized, right? And then once your table are normalized, you can simply go forward with these data model option to relate these tables together. So that will be solving the same purpose which the merge table was solving, or which the merge table the same solution that the merged solution was providing to us. You can have the same solution by making the use of this specific data model itself. But the disadvantage that we were getting because of merge table, that disadvantage you won't be getting over here, right? So advantage you will be getting, but a disadvantage because of merge table you won't be getting over here, right? And that is one of the major reason why you should always go forward with the relationship building among the multiple tables instead of going forward with the merge tables, right? So that would be all regarding the theory, that is regarding the model building. And now from the next video onwards, we will be going forward with building this relationship between the multiple tables that we are having, right? So we have discussed about the merge table relationships, primary key, then the foreign key, and each and every single topic we have discussed about regarding the fact table or regarding the dimension table. And from next video onwards, we will be focusing upon the practical implementation, that how exactly we can relate these tables together, right? So we will be meeting you in the next video with some practical implementation. So thank you guys. All right, guys. So we have discussed about how exactly we can merge the tables together and what is going to be the difference in between merging a table versus building a relationship among the models, right? So now we will be going forward with the practical implementation, that how exactly we can join these multiple tables together that you can see on the screen, right? So now, up till now, we have discussed about that what all different kind of keys we are going to have. We are going to have the primary key, we are going to have the foreign key. And via making the use of these keys itself, we are going to join our tables together. So we are ultimately trying to build a relationship among these multiple tables that you can see on the screen via just making the use of the primary key which you have just associated with respect to each and every single table, right? So this option that you can see over here, that is like an ID card. So that option will be basically giving you this, will be helping you out to join the tables that you can see over here. So you can see all of the top tables we are going to have are the dimensional tables, which are having their proper primary key associated to the it. And at the bottom, we are going to have this fact table, which is not exactly having a primary key, but with respect to the foreign keys which are present in fact table, we are ultimately going to build a relationship among these multiple tables, right? So we have already discussed the way how exactly we can figure out what is our primary key, foreign key. Once we are done with that, then we will be moving forward with managing the relationship. So now in the home tab itself, you can see that there is an option over here, right? This option that is to manage the relationship. So you can simply go forward with this specific option itself, and this can help you out to manage the relationship among the multiple tables that you are having on the screen. So this is one of the option. Still, we are having multiple options to join these tables together. So let us just explore the first way, which will be helping us out to join these foreign keys and this primary key. So you will be working with these primary key and foreign key only whenever you're trying to build a relationship. So that's why it's very important for us to first of all get this idea that what is our primary key, right? So now I will be going forward with this option that is to manage the relationship in the home tab, and let us go with this option, and we are going to build a new relationship over here, right? So let's go with this new relationship option, and now we will be looking into that what exactly is going to be our first table with which I'm trying to build a relationship, right? So on the top, you can always go forward with the dimensional table. So on the top portion itself, you can see that we are having this territory lookup, which is our first dimensional table, which we can go forward with. So I'm choosing my first table as the territory lookup, and you can see a preview of the table as well on the screen, right? What all columns it is having. The complete idea you can see, or you can have by just looking over the preview itself, right? Now, this specific dimensional table, that is the territory lookup, I want to join with respect to my second table, and that is going to be the fact table, right? So our fact table is a sales data table. So I'm going to choose this specific table that I'm having over here. All right. So now we can choose that what exactly is going to be our primary key from each and every single table, right? So our sales territory key is obviously going to be our primary key that is going to be there in our territory lookup. And in our sales data table, we can have a foreign key over here, and that is going to be the territory key, right? So you can just have a look upon the columns itself. In the column itself, you'll get to see that there is always going to be a foreign key in the fact table itself, which will be helping you out to relate with respect to the primary key that you are having in your dimensional table, right? And now you are having this option wherein you can see the cardinality that it is having. So you can see that we are having a cardinality over here as one to many. So those of you who are familiar with SQL, you will be having a kind of great knowledge about that what exactly this cardinality is, whether if it is many to one, one to many to many. So that idea you can definitely have from your side, but definitely we will be going forward with these cardinalities in this section itself. But a brief idea about these things will make it more clear for you that how exactly Power BI was able to figure out that the cardinality among these two tables, that is a territory lookup and sales data, is coming out to be as one to many, right? Now you can also see that there is an option that is showing us that we are basically making the use of this cross filter direction, and that is going to be in a single direction, right? So if I'm just looking over here, then you can see that we can have two kind of direction. Either we can have single cross filter direction, or we can have both as a cross filter direction. So that this aspect also we will be discussing in the further videos, and whether if I want to make this relationship active or not. Again, this option I will get to see whenever when we will be going forward with our previous videos. So in one of our previous videos itself, we will be discussing that what exactly is this active relationship, right? Like we can either have this active relationship or we can have this inactive relationship. So that aspect we will be covering in one of our video in this section itself. But first of all, just let us save it, right? So what exactly I've did is that I've first of all chosen my table, and I've chosen my primary key, and then what exactly I'm saying is that I have first chosen my dimensional table, and from the dimensional table I'm going forward with the primary key, and that I'm connecting with respect to my foreign table with respect to its or with my fact table with respect to its foreign key itself. Now this cardinality is already being detected by Power BI itself. You can also choose the cardinality from your side, but definitely just because Power BI engine is so smart, right? So it will be obviously able to figure out that what kind of cardinality you are having among these tables, right? So let us just go with this option. I'm going to click on save over here, and you'll get to see your first relationship that you're having, right? It's active relationship. You have joined these two tables together. That is the territory lookup with respect to sales data, kind of relationship also you can see over here. So this is a kind of a great option. Like this particular option is already being built for the users who want to go forward with this managed relationship option, right? Or if they want to basically build a relationship among the tables, then they can absolutely go forward with this. But we will be exploring the second way now for the rest of the tables that we are having. But you can see that now we are having a link, right? Now, by making the use of the groups that is present in my first dimensional table, that is a territory lookup, I will be able to extract out the numbers that will be present in my fact table, right? So this relationship building is going to be the important aspect that you have to focus upon while you are trying to build the model, right? So now once you're done with this option, you can go forward with the second way in which you will be able to join the tables together, and that is a drag and drop option. So now from my customer lookup table itself, I'm going to have one of the column which will be behaving as a primary key, which I'm going to relate with respect to the foreign key that is present in the sales data. So you can see we have already our primary key over here, that is customer key. So I'm going to drag it and I'm going to drop it. So this drag and drop option will be giving you the same functionality that you were having when you were choosing these multiple tables. So this is going to be a more easier way to join the tables together. You don't have to go in that option. You don't have to choose the tables. You just have to go forward with the drag and drop. This drag and drop you will be doing in the report view as well. But at this point, you can see that how exactly you can relate the tables together, right? So primary key from one of the dimensional table you have to relate with respect to the foreign key of the fact table. So again, it is able to figure out the cardinality and the cross filter direction. Now I'm going to click on save option over here. Now the second relationship also we are having, right? In your report view itself, you can see that when you were trying to join the two tables together, so I was making the use of this product table, right? This product lookup table I was trying to relate with respect to my sales table. So at this point, you can see that with respect to each and every single category or the group I'm having, I'm getting the similar number over here, right? So this similar number you won't be getting when you will be relating these two tables together, and that is what we are trying to do. So as soon as I'm going to join my product table, or as soon as I'm going to relate my product table with respect to the sales table, you will get to see these numbers getting changed with respect to each and every single category or the group you are having over here. Let me just go forward with this. In my calendar lookup table, you're also having one of the primary key as date. So let us just connect this specific date with respect to our order date, right? You have to drag it and you have to drop it over here. Again, it is able to figure out the cardinality, that is one to many. One to many is the standard cardinality you should have. So we will be discussing about the cardinality first, at what exactly it is. And but one thing you have always have to make sure that you should always come up with the cardinality as one to many itself. Many to many is never preferred. One to one is also fine, but the standard cardinality you should have among the tables when you're having the primary key and foreign key should be one to many only. All right, so now I will be joining my product lookup table and then I will be showing you the change in the number, right? In the report view itself, how exactly these numbers will be getting changed with respect to each and every single filter or the group over here. That I will be showing you as soon as I'm going to join these tables or I'm going to relate these tables together. So now the primary key over here is going to be the product key, which I'm going to relate with respect to this particular product key I'm having. I'm going to save this. Now, if I'm going back to my report view, you can see the numbers coming up, right? And that's exactly how the relationship works. So as soon as you're going to join the two tables together, as soon as you're going to build a relationship among the tables, you will be able to see the numbers from the fact table, which will be getting associated with each and every single group that you are going to have, or each and every single category that you are going to have in your dimensional table. And that is why building a relationship is an important aspect that we need to focus upon, right? So you can see that how exactly relationship is working, right? That these numbers from the fact table are getting associated with the groups of the dimensional table. So this is the major reason why we always used to relate the tables together. So now over here, you can see that we are having the primary key over here as the product category key, but the foreign key corresponding to it is not exactly present over here. And the similar thing you can see over here as well, wherein we are having the primary key as the subcategory key, but again, the foreign key corresponding to it is not present over here, right? So we will be looking into that how exactly we can join these or we can relate these tables together as well in after discussing about the different kind of schemas that we are having. So based on what exactly the kind of relationship you are trying to build among the different kind of tables you are having. So whether if you are trying to build a relationship between the fact and fact table, then for that you can have some another configuration. Along with that, if you're trying to build a relationship among the dimension table, then for that as well you can have a particular schema type, right? So when we will be discussing about that particular schema type, then we will be going forward with building the relationship among these dimension table as well. Right. So for now, you can see that how we can relate the tables together, how exactly we can create these table relationships, and by building these table relationship, how exactly you can see the changes happening in the front end in your report view, or how exactly the numbers are getting associated with respect to the different groups you are having. Right. And that's why it's so easy for. That's why it's so important for us to join that or to relate these tables together, right? Which will be establishing a proper normalization over here as the complete view over here is normalized. And secondly, you are having all of the tables which are being related with respect to each other, right? That will be maintaining the data flow from a particular table to some another table, right? So each and every single aspect we will be covering in the previous videos. What exactly is the data flow? What exactly is the cardinality? And whatever you are looking at that, what Power BI, what all configurations Power BI was able to come up with on its own. So each and every single thing we will be covering in the in the next videos itself. So for this video, you might would have got the idea that how we can build a relationship. So from your side as well, you can try this and then we will be meeting in the next video with some more important knowledge in the field of model building, right? So that's all in this video, and thank you guys. All right, guys. So we have just looked into that how exactly we can create these stable relationship, right? So this building this stable relationship was exactly helping us out to join these multiple tables together, so that I can extract some important features from a specific dimensional table with respect to our fact table, right? So now you can see that how we can exactly build a relationship among the tables, right? That was a kind of easy part. But if you want to make some changes onto the relationship that you have built from your side. So for example, you have related these two tables together on the basis of the primary key and foreign key. But if you want to make some changes, like let us go with this situation, wherein if I'm having this calendar lookup table with the primary key as date, right? And and you can if I'll just hover over here, you'll get to see that what all columns you are considering from your side. That columns you can see from both of the tables, right? So on hovering on this relationship line, you'll get to see that which particular column we have chosen from calendar lookup to relate with respect to the sales data table, right? So this is something you can get by just hovering over here itself. And if I want to edit this relationship, if I'm not interested in the in relating the date column from the calendar lookup table with respect to the order date that is there in sales table, instead of that, if I'm interested in relating that date column from calendar lookup with respect to the stock date, right? So how exactly I can edit it, edit this specific relationship. So in order to do that, what exactly I can go forward with is going to be, I'm going to simply click over here, and over here itself, you can see this option, right? Into the properties option itself, you'll get to see that if I'm just choosing some another column, let us go with stock date. Then if I'm going to click on apply changes, so it will be taking its time. And once we are done with this, if I'll just hover over here, you'll get to see that now the date column, that is the primary key from calendar lookup, is now related with respect to the stock date that is there in the sales data table, right? In a similar way, there is a second way in which I can relate these two tables together. And for that, I can make the use of this manage relationship option. So with respect to this option itself, again, you will be getting this functionality to relate these two tables together. So what exactly I can go forward with is I can first of all look into that specific relationship. So what exactly I'm interested in into is to edit this specific relationship that is between the sales data and the calendar lookup, right? So I'm going to click over here, and on clicking on this specific relationship, you'll get to see that there is a edit option over here, right? So I'm going to click on this edit option, and that will be helping you out to manage and edit this relationship. And now I've just shown you that how exactly you can relate this stock date with respect to the date that is there. But if I just want to go forward with the original column itself, if I want to edit this change, then I can click over here. And now on clicking over here directly, you will be able to relate the order date from sales table with respect to the date column from calendar lookup. And this is the second way in which you can manage this relationship, or you can edit it, right? You have to click on save. Once Power BI is done with this, you'll get to see that, yeah, over here itself, you can see that how exactly from the sales table order date is now associated with respect to the calendar lookup date, right? But it's inactive. So what exactly is active and inactive, we will be discussing about that. So you can absolutely make it active. You can click over here, and again, we can go into that option. We'll be discussing about this thing, that what is active and inactive relationship. But let me just go over here. I'm going to edit it, and you can click over here. You'll get to see this option that we need to make this relationship as active, right? We'll just check this. You are going to save it. And now you can see that we are having an active relationship between the sales data and the product lookup, right? So now we are done with this, and that's how exactly you can edit the relationship, or you can manage the relationship between the multiple tables that you are having, right? Even if I want to delete this relationship, then I'll be just clicking over here. I'll just click, I'll just do a right click. Now after right clicking over here, I'm getting this option to delete this relationship as well, right? So this option you can also have to delete a relationship among the given tables if you are not, uh, if you are not willing to join these two tables together with respect to the given columns, then you can absolutely go forward with this option as well. So we can directly delete it, right? And you'll get to see that now my calendar lookup table is not associated with respect to the sales table. But just because we want its association, so I will be again relating the date primary column with respect to my product date, right? Make this relationship active. Each and every single option you have to choose, and you'll get to see a proper relationship is again built now. So this is exactly how you will be able to manage a relationship, or you will be able to edit a relationship. You can click on a relationship. You'll get to see this properties option, or you can go forward with this option, manage relationship. You'll get to see that which all tables are linked with respect to each other. Along with that, you can even delete the relationship by just right clicking over here, right? So that would be all regarding managing and editing the relationship among the different tables. And we will be meeting you in the next video with some more important videos regarding the model building part, right? So thank you guys. So in this specific video, we are going to discuss about that what kind of schemas we can have, right? So schema is just like the ER diagram. So if you are aware about that, what exactly is a ER diagram? So ER diagram stands for entity relationship diagram that we are having in SQL, right? So in SQL, you are going to have a database wherein into your SQL database, you are going to have these multiple tables. So these multiple tables wherein each and every single table will be storing some specific information, right? So if you want to relate these multiple tables together, then how exactly you are relating these multiple tables together in a SQL database is something defines your ER diagram, right? And that ER diagram is itself a schema that we use to consider, right? So on the screen itself, you can also see that we are having these multiple tables which we are trying to link together, right? So ultimately, we are also trying to link these tables together, which are having a relationship among them, like one to many or this any relationship that you can see over here. So we are ultimately having a relationship over here, right? So This relationship that you can see on the screen among these multiple tables is something we used to refer it to as a schema. All right. And now the schema can be of two types whenever you are going to have a data model. So as soon as you are working with Power BI and whenever you're having this data model, then you can have these two kind of data model, or you can consider it as a schema, right? So that schema is being defined on the basis of how exactly you are arranging these tables together. So for example, over here you can see that with respect to this particular schema, if I'm looking into it, so if I'm saying a statement like schema, then by schema I mean to say a arrangement, right? Schema is equals to arrangement, right? So in this schema or in this arrangement, you can see that my fact table is being linked with respect to all of these dimension tables, right? And whenever a single fact table or a fact table is being gathered with respect to all of these dimension tables, then that is what something we used to refer it to as a star schema. So that is going to be our first type of schema, right? So I'll be writing that down it for you. So my first type is going to be a star schema. And in my star schema, I'm going to have fact table surrounded by all dimension tables, right? That is exactly what a star schema is, right? So just like a star schema we are going to have, we will be discussing about the second type of schema as well. But over here you can see that, okay, let me just give you a kind of a description of the second schema as well. So second schema is going to be a snowflake schema. So this snowflake schema, it is a kind of extension of your star schema itself, which is going to have, which is having dimension tables connected to it as well, right? So you can see on the screen that if I'm giving you a description about the snowflake schema, then it is going to be an extension of the star schema itself, wherein these dimension tables will also be linked with respect to each other. So this line, this relationship line that you can see over here, that line you will be able to see among the dimension tables as well when you're having your schema type as a snowflake schema, right? So we will be going forward with this at what exactly is going to be our star schema. So now if I want to look into my star schema, then let me just minimize it. All right. And now let us have a look upon how exactly a star schema should look like. I mean, a kind of way in which we can represent it. This is also a kind of star schema itself, but a kind of description, a kind of representation we can provide you. So over here you can see that this looks like a star, right? As in the star representation, as you can see, why exactly I'm considering this particular representation as a star schema, just because I'm having this dimension table, first one, second, third, and fourth. So four of these dimension tables are all being linked with respect to a single fact table, right? And whenever I'm having such a kind of schema wherein all of my dimension tables are being connected with respect to a single fact table, or if my data is flowing in such a way such that all of these groups are being linked with respect to this numerical table, then I will be referring this kind of schema as my star schema. So our schema is as well star schema itself as our particular model as well is having all of the properties that a star schema is having. You can see our sales table, which is our fact table, is being linked with respect to all of these dimension tables, right? But let me move forward to the second type of schema that we are having, and that is a snowflake schema. So into the snowflake schema, what exactly we are going to have is the extension of the star schema. So you can see that we are having these two tables over here. That is the product categories lookup and product subcategories lookup, right? And in this particular tables, you can see that I'm not exactly having any column which I can relate with respect to my fact table. So ultimately, I have to look forward to a way wherein I can associate this product lookup table with respect to the product category lookup table. And this product category lookup table will be linked with respect to the product subcategories lookup table, right? So over here you can see that we were already having a star schema. Then I associated my first dimension table, that is a product lookup, with respect to the second dimension table, that is the product categories lookup. And then the second product categories lookup table, that was my second dimension table, that I'm linking with respect to my third dimension table, right? So you can see a relationship is happening in between the dimension tables, right? So an extension of star schema you can consider as your Snowflake schema, which will be having the relationship among the dimension tables as well, so that you can see a kind of proper data flow among the all of the tables that you're having, right? So this is what a Snowflake schema is going to be. So whenever someone is asking you, or whenever you need to get this idea that what all types of schema you can have into your data model in Power BI. So generally you are going to have these two kind of schema, that is the star schema, or you can have this Snowflake schema, right? Depending upon what kind of relationship you are having among the tables that you can see on the screen. All right, and that would be all regarding the star and Snowflake schema, and we will be meeting you in the next video with an assignment that how exactly you can build this model relationship, right? So let us meet in the next video with the assignment, and thank you guys. All right, guys, so here we are with our first assignment. So this first assignment will be regarding the table relationships that we have discussed in the previous videos, and let us go with each and every single key objective that is mentioned over here. So first of all, we have to delete all of the existing table relationships. So we have already shown you a way in which you can delete all of the current relationship that is there among the tables, and you can simply right click onto each and every single relationship. And via that itself, you will be able to delete the relationships that is there in the tables, right? Then you have to create a star schema by creating a relationship between sales, calendar, customer, product, and territory keys. So we have already shown you a way that just because sales was our fact table and these specific tables are our dimension table, wherein calendar, customer, product, and territory are having the respective foreign key, or are having the respective primary key, via making the use of which I can connect with the foreign keys that are there in the sales, right? So again, just because in these specific tables we are having the proper foreign key and the primary key combination, so that's why we can connect it properly in the form of star schema. Then with respect to our three tables that we are having as product subcategory, category, you have to connect them into a Snowflake schema. So in the last video itself, we were discussing that what exactly is a Snowflake schema and what exactly is a star schema. So if you want to connect it into a Snowflake schema, then you simply need to look forward to that among the dimension tables, how exactly you can connect with respect to the primary key of the first dimension table with respect to this foreign key of the second dimension table, right? And that is exactly how you will be able to maintain a relationship among the dimension table as well. So once you are done with this second step only, you will be able to perform the easy third step, as this third step, as we were mentioning in the previous video as well, it is going to be an extension of the second step, right? So first of all, you have to go forward with the star schema. Once you are done with that, then you will be going forward with the Snowflake schema by just connecting these rest of the dimension tables that you are having with respect to the star schema that you are already having over here, right? And that's exactly how the thing used to happen. Whenever you are required to come up with a schema, first of all, you always have to go forward with the star schema. All of the fact tables must be connected with respect to the dimension tables. Once you have connected them, then the rest of the dimension tables will be connected with respect to each other. So that we can arrive at the Snowflake schema from the star schema, right? So once we are done with that, then we can make the use of the matrix, this matrix visual, so that we can confirm that our that filter order quantity values, or we can basically these we can just simply filter these order quantity values using the fields from each dimension table, right? So in the last video itself, we were discussing that how exactly we can go forward with filtering the values. So what we need to do from our side is that in the previous video itself, we were showing you that how exactly the number was getting changed. The number was getting changed via making the use of the different, via just connecting the two different tables together, right? And that is what you are required to do over here as well. You have to simply go forward with those specific table, which will be providing you or which will be helping you out to associate the number with respect to the different groups you are having, right? So once you will be coming up with a proper connection that is there in the second key objective and the third key objective, that in the fourth objective itself, you'll get to see that how exactly a proper value is now being associated with each and every single group that is there in our dimension tables, right? So we have discussed about these things in our previous videos as well, and we have shown you each and every single step. So I think it will be a bit easy for you just because in the last one or two videos only mostly we have discussed about these things, right? So a quick recap can be done via just following these key objectives, and definitely in the next video itself, we will be discussing about the solution of these objectives. But you should try these things from your side, right? And so now we will be meeting you in the next video with the solution of these key objectives. So thank you guys. All right, guys. So here we are with the solution of our key objectives that we were discussing in the previous video. So we will be going forward with each and every single key objective, and we will try to find out the solution of each and every single objective, right? So let us go with the first key objective first of all. So we are having the first key objective to delete all of the existing table relationships, right? So you can see that we have related these multiple tables together. So what exactly we can do from our side is that I can just go over here. I can right click, and if you'll just right click, you'll get to see this option that is delete option. So you can directly delete it, right? You'll get to see this pop-up window that will be asking you that we want to delete this table relationship. So yes, we want to delete it, right? You can click on yes. Similar criteria over here. Right click, delete, click yes. Similarly, right click, delete, yes. Again, right click, delete, yes. All right, so we are done with the first key objective, that is to delete all of the existing model relationships. Now the second key objective is to create the star schema by creating relationships between the sales, calendar, customer, product, and territories, right? So we have already seen that our fact table is having all of the appropriate foreign keys, which we can relate with respect to the primary key, which is there in these specific tables, right? So let us go with the connection, and we'll be after connecting these tables together, we'll get to see a star schema which is being formed. So again, I will be revising what exactly is a star schema. So in the case of a star schema, we are going to have a single fact table or a fact table which is being connected with respect to these dimension tables, right? So that is what exactly a star schema is. So let us go with the connection. So first of all, with respect to our territory lookup, we are having its primary key. So whenever you want to figure out what exactly is your primary key, we have already shown you a way that how exactly you can mention the primary key for a specific table. And then if you want to see that what was your primary key, then you will get to see an icon over here, right? This ID card kind of icon that you can make the use of. You'll just drag it and you'll drop it with respect to this foreign key. You'll get to see a proper relationship, cardinality, and all of these factors. Cardinality we'll be discussing in the next videos. So now I will save it. Here we are with our first relationship. Secondly, with the calendar lookup, we are having this date column, which I'm going to associate with respect to the order date. Then with respect to our product lookup table, we are having product key, which we can relate with respect to the product key of our sales table. Then we can have a customer lookup, wherein we are having this customer key, which I can relate with respect to this customer key foreign key itself. I'm going to save it. All right. So over here itself, you can see that we are mostly done with our star schema itself. So there is no such requirement to arrange all of these tables such that these two tables should be placed over here and these two tables should be placed over here. There is no need to do that. What exactly you want in the star schema is that the fact table should be connected with respect to all of the dimension tables, right? And the dimension tables must not be connected with respect to each other. So as soon as you are going to connect the dimension tables with respect to each other as well, then you will be shifting from the star schema to the snowflake schema, right? And this is what exactly our third objective is. So as you can see that the last two dimension tables we are having is the product categories lookup and the product subcategories lookup, right? So just because we are already having one of the table which is relating to it, and that is our product lookup table, right? So we can just simply rearrange these tables, right? I can put the customer lookup over here and I can put my product lookup over here, right? So that these three dimension tables can be aligned with respect to each other. Okay. So we are done with our second objective as well. Now we will be going forward with our third key objective, and that is to connect all of the three product tables. And that's why we have aligned these tables together, right? So product subcategory, category, and the third product table, that is a product lookup table, we have to connect it in a Snowflake schema. So Snowflake schema is not exactly a kind of big thing. What you can do from your side is that you can simply go forward with the connection of these tables together, right? Already you are having a star schema. Now once you're done with the star schema, then the rest of the dimension tables you have to connect together so that we will be getting shifted from a star schema to a Snowflake schema. So it's not exactly difficult. As you can see over here itself that in our product lookup table itself, we are having one of the foreign key, and that is product subcategory key. And in our product subcategories lookup, we are having our primary key again as product subcategory key, right? So we are going to associate these two columns together. So this is exactly how we have connected our first two dimension tables together, right? You can see a relationship which is being established among these two tables, among our first two dimension tables. And in a similar way, you can see we are having this product category key, which is aligning with the primary key of our last table, that is product categories lookup. So again, I'm going to drag it. I'm going to drop it. All right, so here we are. Here we are with our proper Snowflake schema design. So you can see over here that we are completely done with our Snowflake schema, and that is exactly how it used to look like. You are going to have the relationship among the fact table and the dimension tables. And then once you are done with that, then the rest of the dimension tables will be getting connected with respect to each other. So you will be getting started with the star schema only, and then a kind of extension you can have to get to have your Snowflake schema, right? So once you are done with this, then we will be moving forward with our next objective, and that is we need to come up with this matrix visual so that we can filter the order quantity values using the fields from each and every single dimension table. So each and every single dimension table, that is around six number of dimension tables we are having. So using the columns of these dimension table, we have to simply associate the order value, the order quantity that we are having. So into our sales table itself, we are having one of the column as the order quantity, right? So what exactly we need to do is that all of the groups that we are having over here in all of these dimension tables, with respect to each and every single group, we have to associate a appropriate number that will be corresponding to the order quantity of that group. So in simple words, I can say that a group can be like a country. So with respect to the country like India and then China and then the other countries, these with respect to these countries, you have to associate the number that will be corresponding to the total number of order quantity that we are having with respect to these countries, right? And that is exactly what a group is. So we will be going forward with our matrix visual. So into a report view, you will get to see the matrix visual. You can click over here. You'll get to see this option, add data. Now in the value section itself, we are already having the sum of total order quantity from our sales table or our fact table. So we'll be just adding the values in our rows. Let us go with our first dimension table, that is the date. I'm going to look forward to the date, and you can see that on each and every single date, how many number of orders we were getting. So on 1st January, we got around 4 number of orders. Then on 3rd January, we got around 8 number of orders, right? So these dates, this first date, second date can be considered as a group, right? And this is what dimension table used to provide us. So you can see that just because we have connected our table, that is the calendar lookup table with respect to the sales table, that's why you are getting, you are able to see the values getting changed over here, or appropriate number getting associated with respect to each and every single group, right? Once we are done with this, let us move to our next dimension table, and that is the calendar lookup. So in our customer lookup. So in our customer lookup table, let us go with the column like education level. Okay. So if you are just going forward with education level, you can see that from the bachelors, we are getting these many number of orders from the so those people who are having the degree or the education level as bachelors, they are having this specific number as the order quantity. Then those people who are having the education level as up to high school only, they are having this many number of orders, right? So again, some important answers you can see over here. So again, this is the second analysis. We will be going forward with this in our report view section when we will be discussing about these things. Just now we want to see that whether if we can see the values change or not. Now with respect to our product categories lookup, let us go with the category name. You'll get to see that how many number of order quantity we are having for the bikes, clothing, accessories, right? So again, some good values you are able to see. Let us go with product lookup. In the lookup, let us go with the product name. All right, so you can see with respect to each and every single product name, we are able to see that how many number of orders we are getting for that specific order, right? Again, some good answers you can see over here. Let us go with our next table, that is product subcategories lookup. Let us go with the subcategory name. Again, you are able to see that with respect to bike racks, how many number of orders we are having. With respect to bike stands, how many number of orders we are having. And finally, with respect to territory lookup, so we were discussing all the time, right? Like the country, and that specific aspect. Let us go with this and let us see. So you can see that the each and every single country is a group over here. Again, I am reciting the same thing, that we are having these multiple categories. From Australia, where we are getting these many number of orders. From Canada, we are getting these many number of orders, right? From USA, we are getting these many number of orders, right? So again, with respect to the multiple groups, we are able to associate an appropriate number via just having a relationship among the fact tables and the dimension tables, right? So we are done with all of the tables, and we are also done with all of our key objectives. You can see over here, right? So that would be all in this video, and I think it would be a easy assignment for you, right? You don't have to really do a lot of stuff, right, from your side. And it was a kind of a kind of interesting assignment as well, as you were able to see the first visual appearance, that how exactly you can create these dashboards. Like this matrix is one of the tool itself which you will be making the use of if you want to create a dashboard, right? But you can see from this specific assignment itself that how we are able to create these visuals or these dashboards, right? So that would be all regarding the solutions of the assignment one from our model building section, and we will be meeting you in the next video with some more important learning objectives, right? So thank you guys.